Tim Ealer, how you doing today? I getting a late start on my video today. As you can hear, I'm toned down with a cold or something. So gonna do my best to get through this. I'm gonna split my videos up into two different videos. One for the tropics, like I've been doing, and one for the rest of the nation. So let's get started here. And happy Saturday, by the way. Um, so you can see here, this is the 8 a.m. update from the National Hurricane Center out in the tropical Atlantic. We have a storm that's a system that's moved off the coast of Africa around 10 north latitude, and uh, and this has been a buzz on the social media for quite a little bit now. And the National Hurricane Center is saying that they think it has a 40% chance of developing, which means they are gaining more confidence that something is going to develop in the next 7 days in the deep southern tropical Atlantic. And we have a 96L, which at one time was forecast was more likely to develop, but right now it's right on the edge of the 26C um, sea surface temp um, uh, isotherm here, and also it's embedded in dry air right now. So I can just get back to the page I was on. That'd be good. But here dang it, I'm sorry, guys. Um, as you can see, I have a lot of tabs up here trying to stay organized. Hide this. So over the past day or so, yesterday this was like 20%. Now that's emerged off the coast of Africa. I think soon we'll see maybe when they see maybe a circulation getting more developed, possibly they may start designating this with a disturbance name like AL97, and that'll enable them to track it with hurricane models like the HAFS-A, B, HWRF, which are models that are specifically designed to track hurricanes and using um, nested grids, which allows them to be more fine focused as the cyclone moves. So I know that's kind of down in the weeds, but right now this is in a favorable environment as far as sea surface temps go. But if you look at the satellite loop, you can see, well, it's like a milky appearance, and you can almost see a circulation already in the visible satellite loop coming off the coast. But if you look at the long range infrared, not a lot of convection associated with it right now. And that's unusual when it moves over um, waters that are maybe marginal at this point. And another thing that may be keeping it from developing so quickly right off the coast is sea surface temps and dry air associated with Saharan air layer, which is dust that blows off the Saharan African coast, moves eastward. And this is just the GFS model depiction of where it thinks this dust is going to be. You see how it kind of goes up into where that 96L is. Get further in time, the intensity of dust kind of dissipates, which it looks like the models are latching on to that. I mean, when you have dust in the atmosphere, That indicates drier air in the mid levels and also prevents sunlight from reaching the ocean surface, which reduces the amount of heating, which reduces the amount of latent heat release and thunderstorm development, and lifting the atmosphere. So as this moves eastward, this is as far as this goes. This will likely mix out, and you see it's dissipating to the north as well. Now, this is not uncommon. It usually dissipates towards the middle of the month of August, and usually not much of a factor after that. But you just never know with these storms and drought in Africa, so deserts. And I like to show you these AI models coupled with the European ensemble and high-res models. See, right, this initialization time is 00Z, which was yesterday. I want to see if I have any more recent initialization here. No. These are a little bit behind on the total, when initialized. So the low off the coast, you have that one here, 96L. Not going to worry about that. It wants to hold on to the low, the European high res, and like when the next graph develops, tropical depression, and the European high res wants to develop a low already off the coast there in Africa, which is probably not the case, but as you get further in the mid-tropical Atlantic, you approach the what I showed you here, the 26C isotherm, which is 80 Fahrenheit, which tropical cyclones need at least 80 Fahrenheit if all the things being equal to maintain and develop, and especially develop. If they go over waters a little bit cooler when they're already developed, they can hold on to intensity for a while, but to get stuff going, you really need 80 Fahrenheit, at least 50 meters in depth. One of the driving factors of that is if you have shallow 80-degree Fahrenheit water, which is like off the coast of Florida here, and it gets mixed, like say you have heavy rain off the coast here, that surface water temperature lowers pretty quickly, and the water beneath that is already cooler than that, so then you have temperatures that aren't optimal for development. And also another factor in that, I know I'm kind of geeking out here, but movement of a storm is important, because if a tropical system sits over one area and just churns the water up for a long period of time, it mixes that water, also the rainfall on the surface, which cools the water below 80 Fahrenheit, and it feeds into the cyclone, and if it stays in one position for too long, it will weaken. All the factors being equal, of course. So that's enough of that. So back to this. You see what we got here. Most models, I mean, these models have been in agreement for quite some time about something developing. Now they want European high res wants to develop a hurricane, Cat 1, with a graph, tropical storm, north of the Lesser Antilles, Haiti, Cuba, off the southeast coast here. It's and this is 9 days out, which is if you go back here, this is 4 days from now. So once we get a tropical depression or a low that develops and they start tracking it, they'll likely fly some upper air sounding missions as they get closer to the United States to really sample the upper air atmospheric conditions in real time because they don't have a lot of sound. We can't do balloon launches off in the water. So on the water, although it's technically possible, they don't do that. So they have to find a way to sample the upper levels to see what the upper level flow really is, not what models are saying it is. So that's another thing. And likely hurricane hunters will, if it does move this way and gets closer, they'll start flying missions out here once it gets within range of them to fly out there. So moving on to the European ensemble, I want to go right to the European ensemble. Let's see if we got any more recent runs. No, we don't. This signal has got a more consolidated and stronger, actually, run to run with the European. And you can see here where once all these dots represent model members. So there's 51 members here, and it's really hard to count. And the more intense dots indicate more concentrated agreement and stronger members. See one in here, 66, and lower pressures here. We go over time. Members are, some members want to go into the Caribbean, into the Gulf of Mexico. Some go to the right here. The majority of them, and this is, 12 days from now, and this isn't Tim Ealer forecast. It's just what model guidance and education, as Mitch West says. And I take a lot of nod from him because he really knows how to convey stuff to the public, and he's doing a great job. And he says the same thing. You get this far out, you're trying to educate people, make people aware, not scare people. There's no way to predict exact landfall or strength at this point. And you go back up in time here, you see it doesn't really build in intensity till it gets north of the Caribbean islands. And most models agree this is a scenario that's going to happen, because if you go to the GFS ensemble, this is the latest run. This is a little bit on the 17th. Let's go back to the EPS 17th. They have remarkable agreement between models, and it's very unusual this far out. And that's what gives me a fair amount of confidence that something will develop and it'll be in this area. You can see there's quite a bit of model spread as you get a little bit further out in time. Some want to take it out to sea, some want to be along the southeast coast, and some want to be in Florida. So, and they're all relatively strong. You're talking Cat 2, Cat 3 strength at this point. Maybe 4. Just, there's a lot of factors that go into it. And one of them is wind shear. And if you look at the GFS, the wind shear is, well, you have a system out here, and this is the system we're talking about developing. It's under high pressure, and if you have air that's being evacuated out of high pressure poleward and equatorward, that's the best case scenario for a system with light winds around the center. As it moves, high pressure stays over top. Although wind shear does increase a little bit as it moves over the Caribbean, you could see a trough developing over the eastern U.S. This high pressure over the subtropical high over the Atlantic Ocean breaks down. There's a weakness in the high pressure, and it feels that weakness and moves up towards it. And this is the operational run. It doesn't mean this is where the track is going to be. This is one run out of 31, and it's just what they choose. I don't know how they exactly choose which operational runs, what to show this, but that's beyond what I know. But high pressure breaks down. Looks like you have a tropospheric upper tropospheric trough to the east of it, and a kind of a split trough over the east coast. And this is a pretty common path for cyclones to take. And one of the reasons it's probably being pulled to the north more than anything is it's strong enough where it feels the upper level flow. If you have a weaker system, it'll skirt before. If say it takes till the Caribbean to get strong enough to be vertically uh, to have vertical convection up in the higher levels of the atmosphere, cyclones tend to feel the upper level flow once they get that. But if they're just a tropical depression with not a lot of vertical coherence, if you will, they tend to move in the low level flow, which is westerly, the trade winds. And this is showing upper level winds between 2 and 805, 850 shear. So the deeper reds is more shear, which is bad for cyclone development. And there is some around the eastern periphery here, but it manages to maintain high pressure. You see the high pressure aloft right over top of it the whole time. And cyclones that get strong, tropical cyclones do that. They create their own environment sometimes, and that's exactly what you see here. And when you see a trough interacting with a cyclone before the center ever gets impacted by the tropical cyclone gets impacted by the upper level westerlies here, shear. This is a favorable interaction depicted on the models because this is a lot of polar evacuation of mass and equatorward evacuation of mass away from the cyclone. Like I said before, when you have this favorable interaction before the shear really gets onto the system, which it does when it moves further up, although it wants to keep it pretty strong, it tends to strengthen it, at least for a little while. You see, because there's a trough over the eastern U.S., it keeps from going into the coast there. If you look at, this is another depiction, the EC-AI model. This shows 850 HPA cyclone vorticity, which is a about 5,000 feet or so above the surface, roughly. Okay, don't call me out on that number, but it gives a good indication of the vertical coherence of a system, and showing the vorticity is just incredible right here, which means just how tightly wound the system is when it reaches the Florida coastline there. Is it going to hit southeast? Hard to say at this point, but you can see how this model wants to keep high pressure. You see this high pressure here to the west of it. It doesn't really show troughiness like the other models do. And if this plays out, this scenario, we'll tip our hats to the European AI model. We'll see what happens. And you can see some other vorticities moving through the flow as well. So I won't be surprised we get another developing system further out. Anyway, this is, let's go back to the global and the GFS. And I want to show you I was talking about humidity levels at the mid levels. And this is actually a depiction of how well this holds on to moisture and how intense it gets. You see the deep blues around it. So this is August 19th. This is the GFS depiction of how it will look on the 19th of August. If I zoom out a little bit, you see it here. Dry air to its west. A lot of moisture nearby. Likely insulated pretty well from the external environment at this point, because it's really creating its own environment right there. And this is pretty cool because I'm utilizing the model output from 96L to depict this here on the, because it picks up on it because it's within its range, so to speak. So I'll go back to sea surface temps real quick. You can see how they warm significantly as we get towards the Caribbean, and you can see off the coast of all the way up into the subtropical Atlantic, we have upwards of 30 C plus 29 C. So the conditions are only going to get more favorable thermodynamic wise as we get closer to the continental U.S. That being said, what I wanted to show you too was this isn't it. Sorry, guys. Phase space diagrams, which I think I showed you before. Geeking out again here, but this shows the 26C isotherm, which I talk about. You see how it depicts the cyclone maybe getting right over the edge of the 25C, which will keep it from developing very much. So this shows a lower troposphere thermic wind with a lower troposphere frontal nature, the model's depiction, transitioning to a symmetric warm core cyclone by the time it reaches the Lesser Antilles. Same between the lower troposphere and upper troposphere thermal wind. Very deep, warm core cyclone. Depicting is getting pretty strong, 900 millibars. You can see the SSTs, sea surface temps, how warm they get here, approaching 29, 30 Celsius. As you get closer to the continental U.S., approaching 31 Celsius off the coast here. So anyway, that's about it for the tropics for right now. I'm going to be monitoring this, and I think it's important that everybody does. And just now's the time to check all your plans and things like that to make sure you have everything. If you live on the coast or somewhere close to the coast, just be prepared for whatever might come. That's all you can do at this point. I hope you all have a great day, and I'll be sharing more stuff on social media as necessary. Have a great day. Thank you.